A system of two linear equations in two variables can be solved in one of three ways. There's the graphical method, the substitution method, and the elimination by addition method. I usually just call that elimination. Okay, we are going to start with graphing, with the graphical method, and then we'll come back and talk about substitution and elimination. Okay, all right, so graphical method, obviously we're going to be graphing. Okay, so if you read what it says under graphical method, it says what you do is you're going to graph each linear equation. Okay, so maybe it's been a while since you've done algebra, but if you remember, think about the word linear. Okay, linear equation. Okay, you should see the word line in there. Okay, a linear equation is just a line. Okay, so if you have your two linear equations, you're going to graph each one out. So essentially you're graphing two lines, and the solution or solutions to the system are going to be where the lines intersect. Okay, so that's what you have to do. Take each line, graph it out, look for the intersection points. Okay. All right, so let's refresh our memory about how to graph a line. Okay, so remember, you can also have horizontal lines and vertical lines. We are going to start out talking about lines that are neither vertical nor horizontal, so they have a slope to them. And then we'll get into what a vertical line, or how you can recognize if something's a vertical line or a horizontal line, because it looks a little bit different. Okay, so under the first bullet point here, it says, the following method can be used to graph a line which is neither vertical nor horizontal. Okay, so you're going to graph the line using its slope and y-intercept. Okay, so remember, you're going to get your equation. Remember, your equation is going to be presented to you as a number times x plus a number times y is equal to another number. Okay, this is called the general form of a line. Okay, most of the time, that is how the equation will be presented to you. Not always, but most of the time it will come in general form. And what you're going to have to do is put the linear equation in the form y equals mx plus b, which is slope-intercept form. Okay, so you're converting general form to slope-intercept form. So basically, you want your equation, if it doesn't already, to look like this: y equals mx plus b. You want to solve it for y, not for x. You want to solve it for y. Okay, so once you get it in this format, and we will go over how to do that, once it's in y equals mx plus b form, that's called slope-intercept form, you are going to identify the y-intercept of the line. Okay, y-intercept means where the line crosses the y-axis. Okay, and the slope m. Okay, so remember, y-intercept, okay, all that is where the line crosses the y-axis, and slope, okay, that's the steepness of the line. Okay, you probably remember it as the rise over the run. Okay, so that's what you're aiming for. Okay, I'm going to come up here because I have some room. Okay, once you get it in y equals mx plus b form, okay, what I need you to remember from your math past is that m, the number in front of x, is the slope, and b is the y-intercept. Okay, but you cannot make those identifications unless the line is written as y equals mx plus b. Okay, if you look at general form, slope is not going to be the number in front of x. Okay, you have to rewrite this guy in this format, and then once it's in y equals mx plus b form, then you can say, hey, the number in front of x is the slope, and then the other number, the b, is the y-intercept. Okay, all right, so you're going to take your equation, put it in y equals mx plus b form. You're going to identify the slope, which will be the number in front of x. You're going to identify the y-intercept, which should be the b value. Okay, and then you're going to start graphing the line. Okay, you only need 2 points to determine a line. Okay, so your first point is going to come from plotting the y-intercept, which is again where the line crosses the y-axis. And then what you're going to do to get your second point is use the slope. Okay, from your y-intercept, you're going to apply the rise over the run to get a second point. Okay, and then you can draw your line through these 2 points. Okay, so that is how you graph a line in general. Okay, so like I said, we will get practice with it, but I'm just trying to refresh your memory on the method. Okay, really quickly before we start, I want to talk about how you graph or how you recognize the equation of a vertical line and the equation of a horizontal line. So remember, vertical lines are up and down, horizontal lines are left to right. They may come up occasionally when you have a system of linear equations. More often it will be a line with slope, okay? But you may get a vertical line or a horizontal line. So I want you to know how to handle that in case you see it, okay? So all I have here are 2 bullet points. The first bullet point says the equation of the vertical line passing through a generic point AB is blank. And the second bullet point says the equation of the horizontal line passing through the same generic point AB is blank. Okay, so when I teach this in college algebra, I have people like, you can memorize the rules, which is perfectly fine. But in case you like have a brain freeze on a test or a quiz and you can't remember horizontal versus vertical as far as the equation goes, I want you to just think about the picture, okay? So I've got a generic point right here, like AB. We don't know specifically where that is, but let me do this, okay? Find the equation of the vertical line passing through the point -4, 5. Okay, so we'll do that. And then over here, I'll put find the equation of the horizontal line passing through the same point. Okay, so visually it makes sense of, as far as how the equation is going to work. Okay, so just hang with me for a second. All right, I'm going to plot the point that I set, because for both of these I'm doing -4, 5. So -4, 5 is right here. Okay, so this is -4, 5. Okay, let's start with the vertical line. Okay, so I'm going to draw a vertical line through this point, so that would be the up and down. Okay, so this is what it's going to look like. Okay, so we're trying to come up with the equation of this line. Okay, the problem with vertical lines have no slope. Okay, their slopes are undefined. Okay, so I'm going to write that up here to remind you. Okay, hopefully you remember this from algebra. But vertical lines have no slope, and it's also called undefined slope. So if your equation were y equals mx plus b, like other lines tend to follow, m is the slope, and if you're dealing with a vertical line, the slope is undefined or no slope, what would you plug in for m? Well, you can't, okay? So that's why we have to think about the equation of a vertical line differently than we think about the equations of other lines, okay? So I've got my vertical line drawn through the point I'm interested in, -4, 5, okay? All you need to do is look at a couple of other points on the line, okay? I'm picking them randomly, okay? This is -4, -8. This is -4, -4. This is -4, 0. This is -4, 10. You get the idea, okay? Any point that I pick on this line, any point that I pick on this line, look at what they all have in common. They all have an x-coordinate of -4. So the equation of the vertical line is just x equals -4. okay? It is x equals, if I'm tying it back to the original point, okay, -4, 5. The equation is x equals, vertical line is always going to be x equals, okay, the x coordinate of the point, okay? So if I go back to write my rule for the generic point, okay, the equation of the vertical line passing through this generic point AB is going to be, vertical line is always x equals, and it's going to be the x coordinate of the point. So it would be x equals A, okay? All right, so let's talk about what the equation of a horizontal line would look like, okay? All right, so we are picking the same point, okay? But this time we're going to draw a horizontal line through it, okay? So that's the left-right kind of line, okay? So I'm going to use a different color here. I'm going to put this in red, okay? So here's your horizontal line through the same point, okay? So if you remember from algebra, horizontal lines, they have zero slope, okay? Zero slope is not the same thing as no slope. No slope is a vertical line, okay? Zero slope is the number 0, okay? You can actually associate a number with it, okay? So I'm going to write that right here. Horizontal lines have zero slope. All right. Okay, so this little method, okay, that we did for vertical lines will also work for horizontal lines, okay? So the line we're interested in, this red line, it goes through the point -4, 5, okay? Pick random points on the red line, okay? This is the point 0, 5. This is the point 10, 5. This is 6, 5. This is -9, 5. I picked them at random. Look at what all these points have in common. They all have the same y coordinate, okay? So the equation of the horizontal line is going to be that y always equals 5 on that line, okay? That's it, okay? So if we go to write down our rule, the equation of a horizontal line passing through a generic point AB is, the equation will always be y equals for a horizontal line, okay? And then you always pick the y coordinate of the point that you're dealing with, okay? So y equals b here. That's exactly what we did here, okay? Horizontal is going to be y equals, and it was the y coordinate that was always in common, okay? So I just wanted to show you, you probably won't run into this too often, but in case you encounter a vertical line or a horizontal line, you know how to conquer it, okay? So let's do some actual examples of the graphical method now.